Another piece of the physics puzzle is called friction. There are many different types of friction. Some deal with solids and others deal with gases and liquids, which are collectively called fluids. Our focus today will be on the friction that deals mainly with solids. Friction is the force that opposes motion. Friction is the thing that almost everyone is working to reduce. Over 1/3 of the energy in gasoline is used to overcome frictional forces as a car goes down the road, which also means that 2/3 of the energy goes somewhere else, and that's something that we'll explore another time. Friction is viewed as evil by almost everyone. But what would your life be like if friction did not exist? If friction did not exist, you would not be able to walk. If friction did not exist, you would not be able to ride in a car. If friction did not exist, you would not be able to do much of anything, if at all. So, a little friction is on the list of good things. Most people wrongly believe that friction comes from bumps and jagged edges catching together and thus opposing motion, but that's not true. Sure, bumps and jagged edges do oppose motion, but that's not friction, it's something else. Friction is the attraction of one surface to another surface. The more that one surface wants to hang on to another surface, the higher the frictional coefficient. A frictional coefficient is the number that we use to define how much one surface wants to hang on to another surface. For example, if the frictional coefficient is 0, then the two surfaces slide over each other with no resistance to motion, and if the frictional coefficient is 1, then the two surfaces want to hang on to each other by the exact amount that is holding them together. Let's take a look at what this means in a simple form. If a smooth, flat-bottomed box weighs 1 pound and is resting on a smooth, flat surface, and the frictional coefficient is exactly 1, then it will take exactly 1 pound of force to get the box to start to slide. If the same box has a frictional coefficient of 1/2 or 0.5, then it will take exactly 1/2 pound of force to get the box to start to slide. And if the same box has a frictional coefficient of 0, then it will just sort of meander around the surface on its own. This rarely happens, but perhaps you've seen an air table or the game called air hockey. The puck just floats around on the table, seemingly all by itself. But this is not exactly true. Other forces are at work, and they will be examined in another lesson. If the frictional coefficient is greater than 1, it will be easier for you to just pick up the box and carry it than to try to push it. I keep saying force, as in frictional force, but the force of friction is not one of the 4 fundamental forces. The 4 fundamental forces will be covered in a different lesson, and as happens with science on a regular basis, we learn something new and we have to change the way we look at things. For about 100 years now, we have suffered under the belief that there are only 4 fundamental forces in nature. But some recent discoveries seem to indicate that there might be a 5th force, and it is even possible that all of the forces are really just one force and that we are seeing them from a different perspective. This, however, will be covered in a different lesson. And now back to the friction of solids. There are 3 different types of friction. There's static friction, there's sliding friction, and there's rolling friction. Let's go back to the 1 pound box that has a static frictional force of 1. We know that it will take 1 pound of force to get it to start to slide. But once it has started to slide, sliding friction comes into play, and sliding friction is almost always less than the static friction. That is, it takes 1 pound of force to get the box to start to slide, but then it takes less than 1 pound of force to keep it sliding on a flat surface. If we take the same 1 pound box, but it has a static frictional coefficient of 0.5, then we know that it takes exactly 1/2 pound of force to get it to start to slide. Then sliding friction comes into play, and since sliding friction is almost always less than static friction, it will take less force to keep the box sliding. The more that we can reduce the frictional forces between the two surfaces, the easier it will be to move the box. So now we take a look at the third frictional force when dealing with solids. It's rolling friction, and rolling friction is way less than static and sliding friction. For example, if we take the same 1-pound box and put it on wheels, it will be much easier to move, but there will still be some friction. Heat will be generated and energy will be converted into another form. And this will be covered in a different physics lesson as we continue to take a look at more pieces of the physics puzzle. Now let's take a look at what happens when things are put on a flat surface that is then tilted. When we set a block of wood on a surface and start to raise one end, you will notice that at some point the block starts to slide. If you did this several times, you would notice that the same block starts to slide at about the same angle every time. We will call this angle the rise over the run. The rise can be measured, and so can the run, and we can put these two numbers in a fractional form. The rise is the numerator and the run is the denominator. If the rise is 1 foot and the run is 2 feet, the fraction would be 1 over 2, or 1/2, or in decimal form, it would be 0.5. If the rise is 10 inches and the run is 40 inches, the fraction would be 10 over 40, or 1/4, or in decimal form, 0.25. It turns out that the rise over run fraction is equal to the frictional coefficient. Using the same adjustable incline plane, one can easily measure and calculate the static and sliding frictional coefficients of many different materials. Rolling friction can easily be measured and calculated in the same way. Don't forget to look at the lab manual at the link below.